All right. Hello, everyone, and welcome to this video. It's a continuation on functions of a linear function of x, okay? So the first part of this video, I gave you the 5 steps, all right? The second part, we just solved a simple linear function and also one on cosine, all right? If you've missed the 2 previous videos, please go back and have a look. For this one, I'm going to talk about exponentials and I'm going to talk about fractions, okay? So how do you apply the same rule here, okay? The 5 rules or the 5 steps I gave you to solving the function of a linear function applies here as well, okay? So as first thing, like I said, you need to replace the linear function with a letter and you now add the x over the q to it. So I'm going to say let q, okay, to be equal to 5x plus 4, okay? All right, then when you've done that, then I now replace it. So it's going to be, I'm integrating exponential q. Then I'm going to add dx over dq and dq to it. Can you see? That's it. Now, the second step, I told you that you have to differentiate the linear function separately and then find the x over dq. The dx over dq here, we're going to find for it. So we have q to be equal to 5x plus 4. Dq over dx is going to be equal, when you differentiate this, it's going to give you 5. So therefore, the dx over dq we're looking for here, so dx over dq is going to be 1 over 5. Now, the third step I told you was to replace the variables back into the equation, okay? So we're going to replace it back into this. So it's going to be, we're integrating e raised to q dot dx over dq was 1 over 5 and dq, okay? Now, the fourth step, okay, I asked you to then integrate as normal. So we're going to integrate, we're now integrating eq, all right, dot 1 over 5 dq. You take the 1 over 5 outside, it's a constant, so it'll be 1 over 5. We're integrating eq dq. Now, when you integrate eq, okay, remember I told you when you integrate an exponential, it will still give you that same exponential. So it's going to be 1 over 5 to give you the same exponential. Then the q will be plus c. Can you see? Then the fifth step, I told you, then you now replace the letter with the linear function. So that will now give me 1 over 5. E, the q is 5x plus 4 plus c. And that will be the answer for this. Okay? And that will be the answer for this. All right. Any question? Please feel free to drop it in the comment section and I'll try to respond to it. Let's pick one more. I think that'll be the last example I'm going to do for this function of a linear function. And I'm going to just go straight to the next one on integral of different forms. So for instance, the f prime over f, I'm going to talk about that in the next video. But let's just finish this one. That'll be the last example I'm going to do. I'm going to do on the fraction now, okay? So let's start. We're integrating here, we have 1 over 4x plus 3 dx, okay? It's a linear function, all right? So first step, we said let q to be equal to 4x plus 3. So dq over dx is going to give you what? 4. No. I'm already jumping already, okay? I'm jumping to the second step already, okay? So q is equal to 4x plus 3, then we'll replace it. So it's going to be, we're integrating 1 over q, all right, dot dx over dq, dq. Do you remember? So this is the function, yeah? All right, sorry, I just jumped to the second step. You don't need to follow the steps, okay? The reason why I'm doing the steps, some of the steps you can do it in your mind. Does that make sense? You can do it in your head. You don't need to write it down. But because I'm doing a series to just explain all the steps, that's why I'm fitting all my thought process at the same time, okay? So the next step, so remember I told you the next step is that you need to differentiate the linear function separately, and you now find dx over dq. So the linear function we have is q is equal to 4x. Q is equal to 4x plus 3, right? So dq over dx is going to give you 4. But as usual, we're not looking for dq over dx. We're looking for dx over dq. So dx over dq is going to give you 1 over 4. Okay? Then the third step is that you need to replace all these variables back to the what? The equation. So we're integrating 1 over q dot dx over dq is 1 over 4 dot dq. Then the fourth step, okay, is then we need to integrate it as normal. So we're integrating 1 over q, 1 over 4 dq. You bring out the constant outside, so you have 1 over 4. You integrate 1 over q dq. Can you see? Now, remember from the standard integral, when you integrate 1 over q, it's going to give you ln q. Please, if you missed the series, go to the first video where I talked about the standard integral derivatives. So that's where you get to know this. So that means it's going to be 1 over 4. When you integrate 1 over q, it's going to give you ln q, then plus c. Then the fifth part, the last step, you just replace q back to it. Okay? So it's going to give you 1 over 4 ln q. So ln, our q is 4x plus 3 plus c. And that is the answer for this. Okay. And that will bring us to the end of the functions of a linear function of x. I think that is pretty much. So you can go to the textbook, solve more questions. Feel free to drop me a message or drop me an email if you need any further clarification, and I will try to help you as much as I can. All right, so the next one I'm going to talk about is the integral of a function, okay? Of a different integral form, okay, of different forms of integration. And I will talk about that in the next video. So I'm going to see you in the next video. As I said, don't forget to like, share, and comment or subscribe, so that if you need anything, just let me know, drop it in the comment section, and I will try to answer that as well. All right, thank you very much. I'm going to see you in the next video.